Hey everybody, welcome to Systems Expert. Let's dive into the question.
Hi Clement. Today I want you to design Slack.
Slack. Okay, so there are a lot of things that you can do on Slack. First and foremost, you can communicate with other people, right? Send messages, and I guess you can send private messages and in one-on-one chats, but you can also send like group messages and in channels. And within channels, you have private channels, public channels. But then apart from all this messaging functionality, there's a lot of other stuff that you can do on Slack, like create and delete channels, update their settings, invite people to Slack or to certain channels within your Slack group or organization. So, what are we designing exactly here?
I want you to focus on the core communication or messaging functionality. And that involves both the one-on-one direct messages and the group channels. But I don't want you to worry about channel settings or any of the extra functionalities that you mentioned.
Okay, so then I guess I'll write down just messaging as the core thing that we are handling, messaging. But so in Slack, if I remember correctly from my own usage of Slack, you have what are called organizations, like for basically like the Slack of a company. For instance, the organization for Algo Expert. Do we want to handle this concept? And also for channels, which I guess live under an organization normally, there's this concept of private versus public that I mentioned right before. Do I have to design my system with that in mind?
So each channel belongs to a single organization. And for private channels, let's just focus on users in a channel being access control. We can just forget about the concept of private versus public.
Okay, so then I guess I'll just write down we do have organizations. I'll just shorten it as org. And in that, you have channels, multiple channels, or potentially multiple channels. And then you said, okay, we're just going to worry about what users are in a channel as far as access control, but we don't need to worry about this concept of private versus public. Okay, so that simplifies things. Now, as far as the messaging functionality, let me think. So when you go on Slack, you can obviously send messages to people. You can read their messages, and these are like bucketed per channel, right? You open one channel or one direct messaging channel and you see all the messages in there. But you're also notified when you're on the Slack app of unread messages that you have. Like if you have a channel, for instance, that has a message and you haven't looked at that channel, it's bolded, I think, so you can see that. And if I'm not mistaken, you can even see like people who tagged you in that channel, like how many people tagged you or how many times you've been tagged. Do we want to design our system to accommodate these things, like the unread and the number of mentions, or should we just worry about sending messages?
Yes, you do want to take care of this. And I want to mention one other thing that we'll call cross-device synchronization. And basically, if you have the Slack app open on your laptop and on your phone, and both apps are showing that a single channel, one channel is unread and the same channel is unread, if you read that message on one of your two clients, say your laptop, your phone should automatically register that that message has been read and that channel should no longer appear as unread.
I see. Okay, so then I'll write down the fact that we do care about unread, like unread messages. I'll just put it as unread. And we care about, what was the other thing? Mentions or tags. But then we care about this cross-device. Okay, so plus cross-device. And that makes sense. Cross-device sync, let's call it. Yeah, because when you have your phone, it does update automatically. Okay, so that kind of tells me that we're probably going to need some sort of, instant notification system, probably a pub subsystem, but we can talk about that later. And we're probably going to need that for the actual messaging functionality anyway. But a few more questions before I actually dive into the design. Speaking of applications, because you mentioned like if you have your phone, you have your desktop, do we care about designing the clients, like the mobile app and like the desktop app, or are we just taking care of the back end?
So you'll only really focus on backend systems for the question, but you do want to keep in mind what kind of communication between the client and the server happens.
Okay. So I guess I'll just put backend, and this implies that it's also like a backend integration or how we communicate with the API, I suppose. Um, Let me see if I'm missing anything. I guess, okay, for when you're sending a Slack message, there's a lot of functionality like to a particular message. You can send code snippets, text blocks, emojis. You can even like pin messages in a Slack channel or save them. Should we handle all this extra messaging functionality or no?
No, you can just treat the messages as pure text for now, but we do want to design this in such a way that it's extensible. And maybe in the future, if we have enough time, we can go into handling pinning or saving messages. But for now, definitely don't worry about it.
Okay, so then I guess I'll just put like next to messaging, I'll put basic text. And I won't worry about these other things like pinning and stuff. And my last few questions have to do with the, I guess, scale of the system, because I think I have the functionality like in mind now that we're designing. But how many users use Slack, or how many users are we designing this for? And I guess going even beyond that, when we're talking about an organization or a channel, how big can those get? How many users can be in those?
Right. So Slack has about 10 to 20 million users today. So let's just go with 20 million. So it's
Okay.
the upper bound. And for orgs, let's say that the single largest customer, say it's a tech company with 50,000 people on the same Slack organization. And we can also assume that the largest channel will be of that size roughly. So 50,000 for the largest channel.
Okay. So I'll put 50K per org and 50K per channel. I realize that, like you said, it's not every org or every channel that has 50K, but you're basically saying the upper bound is that. So
Mm-hmm.
that's sort of what I'm going to design around. And then
Yep.
also, since this is a chat application, I'm assuming that we obviously care about like latency. We want low latencies. We probably care about high availability since this is serving so many users. Is that correct?
So yeah, we would care about both of these things, but for the sake of being a bit more focused, I don't want you to optimize for availability. I want you to focus primarily on the latency and the core functionality and making sure that the clients can really have that user experience that we want.
Okay. So I think the functionality I've marked down and I have in mind, we're definitely going to support that, but then I'll just add, yeah, latency. Latency is what we're focusing on. That kind of simplifies things for the availability, I guess. It narrows things down. And finally, are we designing this for a global audience? I'm assuming so, right?
So in general, you would be, but for this question, in order to kind of make it more digestible, let's focus on a single region. Yeah, don't think too much about this aspect of the design.
Okay. Okay, so then it's really just latency as far as like systems characteristics. Let me just rewrite that here, make the Y a little bit prettier. Okay, so then I think that this answers most of what I had, or most of what I was wondering. I'm trying to think of how I'm going to approach this system, because I guess like the messaging functionality seems kind of straightforward, but I feel like there's actually like it's a little bit more involved than it seems, because it's not just my sending you a message and you're seeing it pop up on your screen. There's also like booting up the Slack app and seeing all of the messages that were previously there, right? So there's both this instant messaging aspect and seeing stuff happen in real time, but also being able to look through old messages and old channels, all channels, etc. And plus, I guess on top of that, there's the whole like unread messages, mentions. So I guess what I'm getting at is that maybe we can divide the system into two parts. There would be one part that would be the instant messaging, the real time aspect of the chat application, and one part that would be the like what happens when you load Slack, and this part probably will interact with, like a persistent storage solution of some sort. Does that kind of make sense as a tentative, plan?
Yep.
Okay, so then maybe I'll just write it up here so that I don't forget. We'll have number one, persistent storage, and this is really like on boot, what happens on application boot, and then there's the real time. Let's call it real time, and I'll put MSG for messaging, real time messaging. Okay, so then what probably makes more sense to tackle first is the persistent storage aspect. And like I said, this one is really tied to what happens when you open Slack. So when you open the desktop app or you open the mobile app. And here I'm trying to think. The first thing that you have when you open Slack is you see all the channels that you're a part of, right? And that's probably where, or not probably, that's certainly where you see if a channel has unread messages or how many tags it has. But so that means that you need to be able to get all of the channels that you, the user, are a part of. So what that tells me is that we are almost certainly going to want to store in a persistent storage solution. And I'm really thinking a SQL database because we're going to be querying this a lot. We're going to want to store every channel, and more specifically, probably every channel like per user, or every channel user pair, if that makes sense.
Yeah, I think that would work. And that table would be, I guess, the just the information that's necessary to figure out what channels a user is in.
Yes, and I guess let me think. We probably need a table for every channel to organization pair, because you need to know what channels are part of an organization, right? So you need that mapping.
Right.
But you also need the mapping of every user in a channel. And you're going to be updating these two databases. Like if we even think of functionality that you said we don't have to keep in mind right now, like editing settings in Slack and stuff like that, we would need to edit these two separate concepts. So I think that having two separate tables for that would make sense.
Yep.
Do you want me to write those tables out or write like the columns, or no?
I think these two are fine, but some of the next tables that I assume you'll be coming up with, I'd like you to write the schemas for if they get complicated.
Okay, and yeah, so just to reiterate, for those two, they would be very simple. It would just be, a UUID, a unique ID for the channels for one column, and then for the users, they would also have a unique ID, and then the other table would be unique ID for channels and unique ID for organization. So those would be the first two. So now the next obvious table, which would be, again, just a SQL table that we're going to need, is going to be for all the messages. Because even though, messages come in and you see them in real time, and so we're probably going to need a pub subsystem, like I mentioned at the beginning, you need to be able to retrieve those messages at any given point in time, right? When a user clicks a channel, or maybe even on page load, I guess I'll decide on that in a second, or perhaps you can give me guidance there, but regardless, we need a table where you can get all historical messages for a channel. So yeah, we're going to have one table that's going to be really big, where I think every row is going to represent a message. So this would be the historical messages table. And I suppose, so here I should write things down, right? Like I should write the columns down.
Yeah, let's do that.
Okay, so this would be, messages or historical messages. This would be the table, and every row would have, a unique key or a unique ID. Let's call it just ID. And I guess here I won't write the type, but the type of all of my IDs, what I'm going to call IDs, are unique IDs, UUIDs, universally unique IDs. But we are going to have, let's see, if a message belongs to a channel, perhaps even an organization. I'm not sure that we need the org ID here, but I think we can add it if we want to. It's kind of trivial. But for now, we'll just put channel ID. So this would be the ID that the message is in. You would need a sender ID. So this would be the user ID, the unique ID of the user who sent the message. We would have probably a timestamp for when it was sent at, probably, a body. This would be a string. And any other information that we want to have about messages, we would store in this table. Does that make sense?
Yeah, I like that.
Okay, so then I might just give myself a little bit more room here by just moving everything, kind of condensing everything together. But so yeah, that's our first like big table. I guess the other two are also relatively big, but because for every channel. But this one is really like a huge table. Now, so you load the Slack app. I don't know. I think like on load on Slack, is it fine if we load messages only when you click on a channel? So basically, like we would make a query to get the last 50 or 100 messages of a channel from this table when the user clicks on that channel. Is that seems in line with what the system wants, right?
Yeah, we definitely don't want to fetch messages from all different channels when on boot up, as you call it, because that would just be a lot of data, and most of it is unlikely to be accessed by the user.
Right, because like a lot of channels, like I know that from my own usage of Slack, I rarely go on basically like 90% of the channels in my organization. So okay, then that's what we're going to do. The idea is that you would only query this table when you click on a channel, and this would be, the API call to query this table, the get messages call or get messages by channel would be a paginated API call, and you would probably even specify the page size and so on and so forth. Now, I'm trying to think. So obviously we're going to need also some sort of load balancing and probably some sharding for this, but I'll get into that in a little bit. I want to just make sure that I have the entire storage solution sort of picked out or defined. The thing that I'm missing right now is knowing if a channel has read or rather unread messages, and also the number of mentions. So if I load up the page and I have a channel that has unread messages, how do I know that? Or what does that mean? That means that the latest message or however many messages have come in that channel came later or after the last time that I read it. Okay, so basically we need to keep track at the user level of when a channel was last read, right? Because the only way that you can know if you have unread messages is if you have some data point that tells you when you last read that channel. Does that make sense?
Yep, that makes sense.
So then in that case, I think, I'm trying to think, we need to know we need to have a table that stores the last time a user read a channel. Yeah, so basically I think we're going to have a table that's going to be like last, like read receipts, basically like last read receipts. And this would not be used to give a read receipt to another user, because I don't think that's a thing in Slack. This would just be to know if you have read or not read a channel. And so this would be a table where you have, as a column, so I guess I'll write it here. I'll put read receipts. That's what I'll call it. Read receipts. And this channel would be pretty simple. It would be, ID. Let's add the org ID just for the sake of having it. Channel ID. And I suppose, by the way, I forget if I mentioned it at the beginning, when you get all of the channels, you would issue an API call like get my channels, and that API call would query, every channel for the current user. And those would naturally fall under the current organization that you're in.
Right.
Yep. But so here we have org ID, channel ID, user ID, and then what would we have? We would just have basically the last read or last seen. Let's go with last seen, and this would be a timestamp, right? This would be a timestamp that says when was the last time that you accessed this channel, that you read this channel. And we would write to this database whenever you click on a channel. So the client would have like, a mark as read API call that it would hit, or that it would call, that would update this, the corresponding row in this table. Does that make sense?
Yep. Yeah, that's good.
Okay, so now this is only part of the problem, or part of the solution rather, because this tells me when the last time I read a message is. It doesn't tell me if that means that there's an unread message or a read message in that channel. So what do we do? Well, I think we can, like, maybe we on boot. So we said on boot we didn't really want to get all the messages, right? But maybe it makes sense on boot to just get, for every channel that is like in that response of get my channels, you get the last message in the historical messages table for that channel, and you see if the sent at timestamp came before or after the last seen timestamp. The only thing is, it does seem like we'd be doing that call for every single channel, which we kind of wanted to avoid. And since you would have to take the most recent timestamp, I don't know if that would be like an ideal way of doing it. Another way of doing it is maybe we have just another table, literally another table that keeps track of the last activity in a channel. So it'd basically be like, so like this other option would be, imagine we have, let's see, channel last activity, maybe.
Yeah. Channel
last activity. And this would be also a simple channel, or a simple table, sorry, that would have, ID, org ID, channel ID, but here it would have the last message time. Let's put last message time. And this would be a timestamp, just like the last scene. And so when you boot the Slack app, you request for all of your channels the row corresponding to the channel in this table, and you compare the last message time to the last scene time, and that tells you if it's unread or not. Does that make sense?
Yeah. No, I think that would be good.
It just seems a little bit simpler to have this extra table, kind of like separating concerns a little bit, than to use this historical messages table to get the last message for every channel. Is that,
Yep.
And I guess, maybe one edge case that I might be missing is if the channel last activity is from you, in which case, like, it cannot be unread by definition. So maybe we could have like a user ID for who the last person who sent the message was, and we compare that. If it's you, then you just disregard that. But yeah, I think maybe that makes sense to add. What do you think?
We could do that, or you could use the fact that the read receipts table gets updated whenever you post a message to on the channel, right? Because it when you write a new message to a channel, you're obviously reading that channel, so that should also update the read receipt.
That's true. Yeah. Okay. Yeah. Then that makes sense, and we don't even need that extra thing. Okay. So then I think I'm going to go with this. The last thing that I'm missing about the on boot is the concept of the mentions. So let me just separate these tables out a little bit so that we see things more clearly. So the mentions they're equivalent to read receipts. The only thing is you need the number of mentions in Slack, right?
Yes. So per channel, you need to know how many times you've been mentioned that you haven't read. It's unread mentions for every channel.
Unread mentions. Okay. So then I'm trying to think. So first of all, that tells me that in a given message, we need to somehow store some extra information about like whether or not there are mentions. So this might be kind of tangential, but when someone will be sending a message, either the client will pass in the body of the send message request the mentions, client side mention parsing, so to speak, or maybe the backend will parse it and store the mention separately. But we definitely need, I think, in this messages table to store, apart from the body, the mentions. Does that make sense?
Yep.
Okay, so I'll put mentions here, and obviously, like this, there might be some optimizations that we can make here. Do you want me to focus like on how exactly these mentions are stored, like the exact format or type in the table, or should I just focus on from a higher level, how we're going to get that mention count?
I want you to focus at a high level on how that's going to work, because I think it'll potentially change how you store them.
Okay, so then, I'm trying to think. I think we need something similar to the read receipts, especially if it's unread mentions. Then I think the concept, like the functionality that we have here with this read receipts table, just makes sense. So, I'm trying to, but the thing is, it's the count. So would we store like every single mention, and you query for the number of mentions, or maybe no, maybe you just store a count of mentions. So maybe you do this. You have a table that is last unread user mentions count, last unread user mentions count. I realize this is a little bit of a long name here. But so it's very similar to the read receipts, right? So it's almost like I can copy, let me just copy this entire thing here. So we can paste, it's the same structure, except instead of last seen, it's a count, right? It's a count, and this count is an integer.
Okay.
So count. Yep. Just count. And here, I guess, like when someone writes a message that happens to have a mention for a particular user, we also write to this database or to this table, right? And we increment the count. And when a user marks a channel as read, then we update this count to 0 if it's not 0. Does that make sense?
Yep.
And so, so basically, whatever we store here in these mentions, like I don't even think that it really matters how we store these mentions here. All that matters is when a user marks a channel as read, you update the count to 0. When a user mentions another user, you update this table, the particular, the relevant row, and you update the count by 1 or by 2 or by however many mentions of that user are in a message. Is that okay?
Yeah, that makes sense.
Okay, great. So I think that we have all of the functionality that happens on boot up, and this is our entire persistent storage solution. So there are a lot of tables, and like I hinted at, we probably have 2 API calls that write to these tables. There's the send message and mark channel as read. Sending a message will potentially update this user mentions table, by incrementing counts, and marking things as read will update the read receipts and potentially this, making the count be 0. And obviously also the channel last activity, and sending a message will update the messages table. Now, before I move on to the real-time messaging aspect, the pub subsystem that I've been hinting at so much, we definitely are going to want to shard this database, and we're also going to want to have some load balancing in the mix, because like Slack is big, right? We've got 20 million users. We've got also like very large organizations. The one issue that we might run into here is hotspots. And if we really care about latency, which we obviously do, then we don't want to run into hotspots. So the way to handle these hotspots is going to be to shard all of these tables, all of these, like this entire persistent storage solution is going to have to be sharded. The thing that I'm worried about, though, is that, like, let's say you shard based on organization. or organization size. Like you put, Amazon, which is a big organization, in one shard, and then you put, Algo Expert and 10 other smaller companies into another shard. Like Slack organizations, they're always in flux, right? It's possible that tomorrow Amazon lays off half of its employees and suddenly there's far fewer activity or far less activity in their organization, or Algo Expert triples in size. So what I'm getting at is that we can't just naively rely on like the same shards at all times. We need some kind of rebalancing, some kind of smart sharding that rebalances what organizations are in what shards if we go with a per organization or per organization size sharding approach. Does that make sense, or am I off track here?
No, I think that makes sense. You're not off track. One thing we do have to note is that the organizations themselves aren't that huge, right? We're only talking about 50,000 people. It's not millions. It's not the kind of scale that Facebook or Uber reaches. So it makes sense for one organization to be able to fit on a single shard.
Okay. My one fear there is just that an organization can have a lot of channels, but I suppose that still it kind of bounds the scale of those channels, since those channels only have like at most the number of users in the organization. But okay, yeah, I guess regardless, yeah, we can fit probably one organization at or like the biggest of organizations can fit in a shard. But so the point of the matter is that if this circle here is our database, and here I'm taking into account basically like all of the tables that I've written above here, this is going to be sharded. So this is sharded, but it's sharded with this sort of smart sharding approach where the shards are rebalanced accordingly, and we probably need some auxiliary service, which maybe I'll mark here, that does this smart sharding asynchronously, right?
Right.
And this could be like a key value store, right? This could be a very highly available key value store like etcd or Zookeeper that maps like organization ID to shard, and that way clients know what shards to hit. And I guess not clients, because we would probably have like a set of API servers. So okay, if here we've got clients, right? These little white circles here are our clients. So literally you or me, if we're loading the Slack mobile app, we make requests to, let's say, send a message or to get my channels, get all the messages, whatever, right?
Mm-hmm.
You've got a bunch of API servers here in the middle. Right, so I'll just put servers. And here there's some load balancing before the servers. So LB, our clients are issuing requests, to the load balancer. The load balancer then issues or redistributes or rebalances these requests to the API servers. And here we can probably just do like a round robin or something, because it doesn't matter which API server we hit. However, the API servers, when they go to the database, they need to know what shard they're going to. So if a client is from one particular org, they need to go to the corresponding org shard. And to do that, they consult with this smart sharding like solution, let's call it, to know that. Does that make sense?
Yeah.
Okay. So let me think. I think this handles everything related to that like first part of the system, the non-real-time part.
Right.
Now maybe we can do the real-time part. So the real-time part would go, let's put it to the right here. Let me think. What is the real-time part exactly? Well, I send you a message. We're both on Slack. Because if you're not on Slack and I send you a message, the next time you go on Slack, you'll be one of these clients here, and you'll just go through this entire system, and we've covered that. If you are on Slack and I send you a message, you need to get that in real time. So that means that you'll still be one of these clients, right? You'll be here, you'll have loaded and booted up the platform, but then you need to be basically listening to real-time messages. And when I'm sending you a message, which is also going to go through this system here, because I'm going to be writing to our historical messages table and all that, I need to somehow push that message to you.
Right.
So what I'm thinking is that these API servers here, part of their job, or maybe, they have sibling servers, I'm not sure, but part of their job, or maybe, it's a cluster of API servers, and, after they write to the databases, they push to the real-time part of the system. But so that will go to a pub subsystem. So here, maybe I'll put some arrows like up here like this. And here we've got a pub subsystem. And I think, we can just go with, like, let's say Apache Kafka. So we're going to have a bunch of Kafka topics. Put them as rectangles like this, right? You've got a bunch of Kafka topics. And these, whoops, I shouldn't touch the smart sharding. Let me just rewrite that here. These Kafka topics are in charge of, getting all of the messages that are being sent by clients or by the API servers and coming from clients, and then basically pushing them all the way back to clients, all the way back to the correct clients who should be listening to them. But I think, we're going to have some sort of intermediary set of API servers. So I'll write red circles here again. So these are just servers. And these servers are basically subscribing to the Kafka topics. So these servers are subscribing to the Kafka topics, right?
Okay.
I guess this is kind of like a two-way arrow, a bidirectional arrow. And then they send the information back to the clients. And I guess when I'm saying send the information, whoops, I have two S's on these servers here. When I say send the information, I mean, like, we clearly have to have some sort of long-lived connection, right? So we can do a long-lived TCP connection, WebSockets between the clients and these API servers. That's how we're going to get that instant notification of a new message. Does that make sense so far, or should I keep going? Or
no, that makes sense. Keep going. Let me know.
Okay.
When you hit a wall.
Okay. So then, I guess I'm trying to think of if it is as simple as this. Well, no, because so in the same way that we had to shard our database here, we're gonna have to shard these topics. Because we're not gonna send every single message to the same topic or to a random topic. So what I think we can do is we can probably follow the same smart sharding strategy where these API servers notify or push to a topic based on org ID, based on the organization that corresponds to that topic. And we follow the same smart sharding strategy to pick the topic. By the way, I'll just put PS topic here. And then here we need one API server or one cluster of API servers to subscribe to each topic, right? And then these clients, so I guess if this API server is subscribing to, let's say this PubSub topic is Algo Expert. I'll put AE. This is the Algo Expert org topic. This API server is subscribing to that. But if this API server is pushing all Algo Expert messages here to this topic and following this smart sharding strategy, this API server might need to follow this smart, or maybe what we can do is we can have a load balancer. Okay, yeah, so this is what we're going to do. We have a load balancer here. We have our clients. Our clients are streaming from this right part of the system. The streams go to, or the long-lived connection go through the load balancer, which itself is communicating with the smart sharding solution to know what API server it should basically assign to a client. And it picks that. It basically says, oh, smart sharding says that the Algo Expert org is this topic, which this API server is subscribing to. So I'm going to redirect Clement here, who is in the AlgoExpert org. I'm going to redirect this route this long-lived TCP connection to this API server. Does this make sense? I know that I'm kind of like rambling a bit.
No, that's good. There's only one thing that's missing, and it's the cross-device synchronization. You haven't really talked about how that gets solved.
Remind me, what was the cross-device is like if I have my mobile app open and you have I have my mobile app and I have my desktop app and there's an unread channel and I open it on my desktop and it suddenly gets read on my mobile. Is that what you mean?
Yeah.
Okay. So let me think. Here, this captured like sending a message and receiving it instantly. But here you're saying that you want me to receive like my own read receipt instantly, basically. So yeah, maybe I think the solution is we use this exact system that I just drew out. It's just that when we push messages, and by the way, the word messages is a bit confusing here because we're talking about Slack messages, but we're also talking about PubSub messages. Let's call them maybe like notifications. When you push a notification to a PubSub topic, that notification could be a Slack message or it could be a read receipt. So if I were to maybe draw out here, let's put it up here, a message like a PubSub message or a notification has a type. Right? And it would have, like, type would be either message or, RR for read receipt. And probably we could have even other types. I can't really think of anything off the top of my head, but, this is extensible. And then you would have a bunch of other information, like, probably, user ID, so the person who sent this, org ID, channel ID, right? Maybe I guess you would even have mentions in here, and then you do the logic of, oh, if this is a message for a particular user, like for this client here, and it has a mention in it, then this client will now update the channel that has the mention to show one mention.
Okay.
Or if there are already mentions because you booted up the Slack app and there were like 5 mentions, well, it just increments it to 1 on the client. And of course, this is the nice thing about the system, is like, if you got a notification up here, like through the PubSub system, that means that a client first wrote to our persistent storage, which means that if the client here like receives a notification and then just refreshes the page, they will now have the updated information in the persistent storage, and so everything will kind of be like as it should be. Does that make sense?
Mm-hmm. Yep.
Yeah. Anyway, I'm just trying to think. Let me just walk through like one edge case. Imagine we're both on Slack. I come on. I don't have any unread messages. You send me a message. I get the notification. So I show that I have an unread message, let's say in like our one-on-one chat. And then, if I don't open that message and don't mark it as read and I refresh, what I just said happens. Like you, Antoine, will have written to the database, and I will have my last channel activity will be updated to have a very recent message, but my last read receipt for that channel will be older than that, so I'll have that new read receipt. And if I do look at the channel, like when I get the notification, then I'll write to the database with the mark as read, and if I refresh, then it'll be marked as read. And the beauty of this is that also, like if there's a network issue and we get a PubSub notification twice, it's effectively idempotent and effectively doesn't have, it doesn't impact, it's not going to make me, have an unread channel twice. I won't be able to mark a channel as read and then get it unread again, because everything will also be in the persistent solution.
Right. Okay.
So I think that covers it all. Is there anything else that I'm missing?
I think that's all I wanted to hear. So unless you have other questions for me?
Nope. All right. Thanks.
Thanks so much.
With that, we hope that you found this video informative, and we'll see you in the next one.